Continue to talk about logarithms. Yesterday we introduced the idea of what a logarithm is, saying that the logarithm is the inverse of the exponential, or a way to undo an exponential. So, if I have 2 plus x minus 2, what do I get? X. Because in our inverses, they undo each other. What about if I have 2 times x divided by 2? X. Because multiplication and division are inverses. They undo each other. What about if I have the square root of x squared? X. Because squaring and square rooting are inverses. They undo each other. So when we're using inverse operations, adding, subtracting, multiplying, dividing, squaring, square rooting, they undo each other as long as we're doing it by the same value. Now if I had 2 plus x minus 5, that doesn't clear each other out because it's by different values. But if we're using the same values, an inverse operation will completely clear each other. So yesterday we learned that logarithms and exponential functions are inverses of each other. Out, as long as we're using the same values, which would be the bases. So if the base of an exponential cancel each other out, just like adding to and then subtracting to. Or if it's written the other way, the base of the exponential and the base of the log. Either way, I have an exponential function and a log function with the same base. They will cancel each other out, just like adding and subtracting or multiplying and dividing. So in this question, I have an exponential because I have 10 to a power of something, so that's an exponential. 10 to the power of log 2. What is the base of the exponential part of this?
10.
The 10. That big 10 that has a power, that would be our base of the exponential part. What is the base of the log part?
10.
How do you know that?
Because log plane is 10.
A log with no base written has a base of 10. Yesterday we defined that to be the common log. We said it's called the common log because our number system is set up by tens, like our decimal places are tenths, hundredths, thousandths. So our number system is set up by tens. So if you just see log without any base written at all, that's a common log with a base of 10. Just like when we write a square root, we don't have to put the little 2 there to say it's a square root. We assume it's a square root. If you see a log with no base written, it's assumed it's 10. So our base of the exponent is 10. The base of the log is 10. That's like adding and subtracting. They're going to cancel each other out and just leave me with the 2. The log and its base can't really be separated. So when we cancel out the 10 and the log of base 10, that all cancels to leave just what was inside of the log. And our second question, what is the base of the log?
3.
3. What is the base of the exponential? 9. They are not the same. If they were the same, they would cancel, but they're not the same. So our goal in problems like this is going to be to try to make them the same. So how can I rewrite a 9 as a 3?
Times
3 squared. 3 squared is 9. So I'm going to rewrite that 9 as 3 squared so that it has now the same base as the log. So the base of the log is 3, and now the base of the exponent is 3. So the log base 3 of 3 undoes each other to leave me with just the 2 times x. Multiplied, not as a power, because our rule for power to a power is that we multiply. So that's 2 times x there.
3 and a 9. That's a stupid question, but how did you get that from?
I rewrote the 9 as a 3 squared because 9 is, and I want to make the bases be the same. So since I already had a base of 3, I want to try to work the other one to be a base of 3 as well.
If you can like cross out tens, like those like numbers, couldn't you like divide by 3 and get log 1 to?
We can't divide because there's no multiplication happening here. So dividing is what undoes multiplication, but this isn't a multiplication problem.
What if it was the opposite, like log 9, 3 to the x?
Good question. It won't be. So don't worry about that case. We're going to be rewriting the exponential base to match the log base, not vice versa. To write an inverse, this is something we studied back in chapter 7, which was a long time ago, even though we're just on chapter 8. We skipped around. So chapter 7 was a long time ago before Christmas. We did mention it yesterday, though. What's our first step in finding an inverse function? Switch the x and y around. So first thing I'm going to do is just change the x and the y's position in the equation. Then we want to get the y alone. And we can't get the y alone by like dividing by log of 3 because this isn't log 3 times y. We do multiplication by dividing. This is not a multiplication. The way we undo a log is with its inverse, which is an exponential. So we want to rewrite this as an exponential statement, which was what our first 5 problems yesterday in our notes practiced, was how to rewrite or rearrange from a log to an exponential or vice versa. So when we did that, we said our base stays the same. So what will the base be? 3. And then what happened to the other stuff?
Like x to the power of x equals y.
Yep, they swap positions. So 3 to the power of x equals y. And this is our inverse function, but this y is different than the original y because it's the inverse function. So back when we studied inverses, what did we have to do to denote that it was an inverse? What was our notation for that? The little -1.
Why does the log disappear?
It's rewriting it in a different format. So there's been a lot of confusion with this. So I want to try to do another example. When we rewrite from a log to an exponential or vice versa, it's kind of like saying I could write x over 2, which is a division problem, as 1/2 x, a multiplication problem. So when we move from a log format to an exponential format, we're just rewriting it in a new format.
Wait, why do we need that -1 over y?
We need that -1 because that's what denotes that it's the inverse of the original. It's not the same as the original y equals equation, it's the inverse of the original y equals equation.
So if it were like the normal equation, it would be x to the 3rd equals y. Or just doing
3 to the x, not x to the 3rd. Our x is going to be our exponent because it's an exponential, and that's what the phrase exponential means, is that x is the exponent. So when we move between the 2 lines that I wrote in the blue, in like our first 5 problems yesterday, when we're rewriting a log as an exponential or an exponential as a log, we're not changing the equation at all. Everything is exactly the same. We're just kind of rearranging it. Just like x over 2 is exactly the same thing as 1/2 x, but one of them's using division and one of them's using multiplication. These 2 statements written in blue are exactly the same, except one of them's written as a log and one of them's written as an exponent. Okay, so it's just a rearranging of a statement that maintains the truth and the validity. Everything's exactly the same. So in our next one, to find the inverse, first step is swap x and y. Then I want to try to get y alone. And the way that I get y alone is by turning this into an exponential statement instead of a log statement. To make it an exponential statement, I need to know what the base is. What is the base E. The base of the natural log is E. It won't ever be written there, but that's what it is. The base of the natural log is E. So when we rewrite this as an exponential, the base stays the same, and the other stuff switches locations. So E goes with the x now, and the y plus 1 is all alone.
Wait, will this be y to the -1?
We're not done yet, because I need to get y totally alone. So I need to subtract 1 from both sides and get e to the x minus 1 is equal to y, but this is the inverse of the original y. So we'll use our inverse notation. So to find an inverse, we swap the x and the y statement as an exponential statement. Okay. Questions? To graph. We're going to take care of any shifting first. So this minus 1, what is it going to do?
Move the right one, or no, it'll minus it down.
So how do I decide whether that's a sideways shift or an up-down shift? Because it's right by the x. So how do I know? It's not in parentheses. It's not grouped with x. If it's connected to the x by being grouped in parentheses, then it would be a sideways shift. This is next to the x, but it's not grouped. It's a downshift of 1. So we're going to begin by shifting the entire graph down 1 position. Then, like we did before, we're going to work now just with the part of the equation we haven't done. So we can ignore that minus 1. When graphing, it's nice to be able to make an XY chart and plot some points, but I don't really know how to evaluate logs very well. So if I would like pick a number and plug it in there for x, I don't know what log base 1/3 of 4 is. And your calculator can't do it. So we need to rearrange this statement into something that we're better at evaluating than logs. And we're better at evaluating exponents than we are at logs. So we want to rewrite it as its exponential form. So like we did yesterday, the base stays the same, and the other stuff swaps locations. So 1/3 to the y is equal to x. And those are equivalent statements, just like 1/2 times x or x divided by 2.
How come we didn't swap the x and the y?
We're not finding the inverse. So when we're finding an inverse, that's the first step. But in these, we're just graphing the actual function. So now we're going to make an XY chart, but if I choose x's, then I would have to solve for that y. So instead of choosing x's, I'm going to choose the y values, since that's on the same side of the equation as the numbers. And that way I can just plug stuff directly in and not have to solve for anything. So if y is -1, 1/3 to the -1 is 3. 1/3 to the 0 is 1. 1/3 to the first is, and 1/3 squared is. Now we are going to plot these points from our shifted line. So from that shifted line, I'm going to go over 3 and down 1. Over 1, up 0. Over 1/3, up 1. And over 1/9, up 2. Before we connect these dots, we might expect our graph to look like. We're graphing a log function, which is the inverse of an exponential. We've done a lot of exponential graphing. When we graphed an exponential, what kind of asymptote did our graph have? It had a horizontal asymptote. There was a flat line side to side that our graph is following along. So if this is the inverse, what might we expect it to have? A vertical asymptote, a line that it won't cross vertically. And so that's what we see happening here at this y-axis. We have a vertical asymptote that graph is never going to cross, but just follow along as it takes its turn out to the side. So just like our exponentials took a turn up or took a turn down, these are going to take turns out to the side.
So does this mean that
Got it, exactly. So in our exponential, domain was unlimited. Since this is the inverse, everything is backwards of that. So our range will be unlimited. We can see it's pointing forever straight up. And then even though it's getting pretty flat out to the side, it is still ever so slightly. Our range will be unlimited, but our domain is blocked off by that vertical asymptote. Domain talks about x. It's going to be greater or less. Greater because it points to the right, and where is it cut off? At 0. So our exponentials had unlimited domain but limited range. Our logs are the opposite of that. Questions? We start with our shift. What does that plus 2 do? Horizontal shift to the left. To the x, it's a sideways shift. So we are going to go to the left 2 spots to create a new spot. And the equation we're going to work with is just the other side. We haven't taken care of the log base 5 of x, but that 2 we're done with. We are going to rewrite this as an exponential because we can evaluate exponents but not logs. So we're going to write it as 5 to the power of y equals x. When we move between a log statement and an exponential, the base stays the same, but the other stuff swaps locations. Choosing since y is on the side with the numbers. So when we plug in a -1, y to the negative 5 to the -1 is 1/5. We'll see if it catches up. 5 to the 0 is 5 to the first is 5 squared is 25, and I'm not going to plot that because I'm not going to go over 25. Now we plot these from that shift line over 1/5 down 1. Over 1 up 0. And over 5 up 1. It follows a vertical asymptote and takes a turn out to the side. Our domain will be limited by that asymptote. Is x going to be greater or less? 2. Because that's where that asymptote is. That's where our graph is getting cut off. And our range will be all real. It's completely unlimited. This graph is going forever downward and forever upward. It's just going upward very slowly. But it is going upward. Questions? On your homework, you will be asked to graph some ln graphs, or natural logs. So let's just think for a minute what that would be like. If you needed to graph y is equal to the natural log of x. This one doesn't have any shifting, so we wouldn't need to worry about that. So then our first step would be to rewrite it as exponential. Make our chart. What's the base?
E.
So we would say e to equals x. Our chart for that. LNs are just logs. They just have a very special base. Okay? But they behave exactly like any other log. They just have a very special base. Okay? And remember that if you see a log and there's no base written, the base is 10.